All right, the next type of naming that we're going to be learning is how to name linear alkanes. And these are going to be extra credit on your test. So if you're interested, then pay attention. And I think for these, you need slow and steady wins the race. Now, this particular type of naming is for a covalent compound. But just like with ionic compounds with acids, which acids are ionic compounds, they have a special naming. Some covalent compounds are named a different way, and that is with an organic type of nomenclature. So what makes up organic compounds? Basically, they have a carbon and a hydrogen. In this class, we are going to say that these compounds, these alkanes that I am going to expect you to know, will only be carbon and hydrogen. A lot of times you'll have different groups also on these, attached to these, but in this class, we will only be dealing with carbons and hydrogens. They will never be something else. So how do you name an alkane? First, you have to identify the straight chain. Okay, straight chains are pretty easily. How do you identify it? It's got only carbon and hydrogen. And for this class, once again, right now, all we're going to be worried about is if they are single bond, okay, to each other. So right now, you don't even really know what double bonds are, but as of right now, this only works, the alkanes only work for single bonds, okay? And so for this class, once again, they're only going to be made up of carbon and hydrogen. And this, once again, will be extra credit on the test. So how do you base it? What do? You base it off of the number of carbons present in the chain. So for example, if we have like these are different compounds right here. Okay. What you do is you count how many carbons you have. Because once again, these are all going to be straight chain, meaning there's no like double bonds and stuff like that. They're all going to be single bonds. So all you have to do is figure out how many carbons do you have in one single row. So each carbon is connected to that same to another carbon. So in this one, we have 2. So this would be eth. So you use the prefix of eth, and then you just add the ane ending. So this would be ethane. Okay, the next one, I see 3 carbons, and 3 carbons has the prefix of prop, so this would be propane. Then we've got C4, so 4, unlike with the covalent compounds, its prefix is bute, so this is butane. Okay, so this is how you do it visually when you see the actual carbons, is you just count them. So let's try to do the bottom. Okay, so in this carbon, I only have 1. So I'm going to erase. So this carbon would have 1, so it would be methane. In this case, in the C2H6, I see 2 carbons, so that would be ethane. And then the C9H20, that would be nonane. So basically you figure out your straight chain or your number of carbons, and then you build off of that. All right, so that's the simplest type. But what happens a lot of times is you get these little branches. So if I look at this picture down here, I see this branch of different things, different carbons branching off of one straight chain. Okay, so how are they different? You see the branch alkanes differ because the carbon chains substitute a few hydrogens for carbons. So typically on a straight chain, this would have been a hydrogen, which means that these can't bond with it. Same with these. This would be a hydrogen down at the bottom, and these would be hydrogens. Well, hydrogen can only bond once. This will be talked about next semester, but in this case, it actually is attached to a carbon. So therefore, you see these carbons attached to them, and therefore it's not a straight chain anymore. All right, so how do you name branched alkanes? First, you need to count the largest continuous chain of carbons, okay? Sometimes because of how it's written, you have to be very careful with how you're counting. So in this case, this one seems pretty easy. If we see, when I ask you to draw these, I'm only going to ask you to draw the carbons. I'm never going to ask you to draw the hydrogens. Since we haven't learned how to draw hydrogens and how things are bonded, just worry about the carbons and where they're located, okay? Because that's the most important anyways for alkanes. So what you want to do is you want to count the largest continuous chain. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 1. Now I could have looked at this one. 1, 2, 3, 4, 5, 6, 7, 8. So in essence, I could have used that chain as one of my straight chains also. What I couldn't do is count this guy right here as my start of my chain, because if I did that, it would be 1, 2, 3, 4, 5, 6. And I was able to get to 8 with my other way, so 8 would be a bigger number. So you always want to go with the longest straight chain. If you look at this one down here at the bottom, okay, if I just went straight across, I would only be able to get up to C6. But that's not the most, because if I had done a loop more like this, I would have gotten to C8. So you need to count your largest, and that's going to be your pentane or your hexane or your octane in this case. Okay, that's going to give you the ending part of the name. All right, so this would be an octane then because of these 8. So we've already figured out the chain, the longest chain. Okay, now it says number the carbons in the chain starting with the end that's closest to the branch. Okay, where these branches occur. So I'm going to circle the branches in this case here, here, here. Okay, this is the exact same structure. It just looks different. So here's a chain, here's a chain, here's a chain. All right, when I look at this, it says number the carbons in the chain starting with the end that's closest to the branch. So as they drew it, they numbered it. We have a branch off of 3, 4, and 5. Now if I drew it the other way and labeled this as carbon 1, 2, 3, 4, 5, 6, 7, 8. I have my branches starting at 4 all the way to 5 and 6. Okay, whereas on this one, where I went this direction starting at 1 going to 8 in that direction, I started my first branch at 3. So that's how you need to count them. Okay, so you're going to start on the longest chain, which is C8, and then you're going to figure out which direction gets you to the chain the fastest. In this case, it would be going from the left to the right, so therefore we would be counting these guys as 1, 2, 3. All right, now you need to count the number of carbons in each branch, and you're going to add an "il" after it because they're called alkyls. So this guy right here, I see 2. So it's the same prefixes as were for the previous one for the alkane. So you got meth, eth, prop, bute. So this chain has 2. So if you look at your previous one, that is an eth group. So this chain would be known as ethyl. Okay, this guy would be 1, so that's methyl. This guy, which is also a branch, is known as methyl. Same with these guys. So this would be ethyl. It's the exact same structure. It's just looking differently. And these would be 2 methyl groups. Okay. Notice that they're not connected, these 2 carbons. So that's why they're individual methyls. Okay. So the next one we're going to do is attach the number of the carbon from which each substituent branch, okay, to the front of the name. So, and then it says if 2 carbons are attached to the third carbon, then you call it 3-ethyl. So what that means is we've got ethyl. So this was ethyl. This is methyl. And this is methyl. So right now I have the ethyl at 3, so you write 3 dash. Methyls are found at 4, so that'd be 4 dash, and this methyl would be at 5 dash. Okay, exact same thing would happen down there. Now place the names of the substituent groups in front of the name of the parent chain in alphabetical order. So in this case, I'm dealing with ethyl and methyl. So which one would come first? You are going to put ethyl because it comes first alphabetically because it has that E. Now, you are going to write I only have 1 ethyl, so it'd be 3-ethyl. Okay? These 2 groups, on the other hand, this guy right here and this guy right here, were both methyls. So what they do to kind of condense, they do a dash. So in between your different alkyl groups, you're going to put a dash, and then you're going to write down where the methyls are found. So that would be at 4, 5. You separate them by commas. So if they're part of the same alkyl group, you separate them by commas. Do a dash, and then write down what they are, which is methyl. But because you have 2 of them, now you're going to go back to the covalent prefixes, and this would be dimethyl. Okay, and then what you do is you then write down how many of the main chain you have, which was octane. And this should not have a space, but it goes dimethyl octane. Okay, and you don't put a dash in between your last alkyl group and your main chain one. So it'd be exactly looking like that. Okay, and then you also, as I mentioned before, you need to make sure that you put those prefixes in before. All right, so let's just try some practice problems. So I'm going to count first. So there's 1, 2, 3, because I want to find my longest chain. 4, 5, 6, 7, 8. So that's got 8. And then if I go up here, 6, 7, 8. So I'm going to go with this one as being my longest chain just because it's written that way. So 8 would, I know that this is going to be an octane. I'm going to work backwards. Now I need to find my little subgroups, okay? So I've got my methyl, and I've got whatever this guy is. So this is methyl, and this is 1, 2, 3. So it goes meth, eth, prop. So this is propyl. Okay, now you have to figure out what direction the branch comes from first. Okay, so if I count my carbons, it's 1, 2, 3. So I get to my first branch at number 3. Whereas if I go from this direction, I get 1, 2, 3, 4. So the 3 direction gets me there faster. So I know that this is going to be 3-methyl, and this is going to be 4. So this is 5. So 5-propyl. Okay, there's no other branches coming off, so I'm not going to have to make it a dimethyl or dipropyl or anything like that. So now I just need to put in alphabetical order. M comes before P, so I'm going to write it as 3-methyl dash 5-propyl octane. So that'd be the name for that guy. All right, let's try this guy down here. So we've got 1, 2, 3, 4, 5, 6, 7. That's my longest branch. So this would be a heptane. Okay, now I need to figure out my other branches. So I've got 1 here, 1 here, 1 here. They are all methyls, so I know I'm going to be a trimethyl. Now I need to figure out where the first branch comes from, depending on the direction. Here the first branch comes, if I start from the left and go to the right, my first branch is attached at 3, at carbon 3. If I go from the right and go to the left, it's 1, 2, 3. So they both have 3, but if I look at this guy, I have 2 coming off of that third branch, whereas this one I only have 1, so I'm going to go with the one that has 2. So that's why it would be 3, 3, 5-trimethyl with no dash heptane. All right, so now we need to draw ours. And I'm not going to ask you to draw any carbons. I actually think these are a lot easier than the other way. I'm not going to ask you, not carbons, any hydrogens off of these carbons. All I care about is where the carbons are positioned. So when I'm going to try to draw this, first I'm going to figure out my longest chain. So butane is meth, eth, prop, but. So that would have 4. So I'm going to draw a carbon chain of 4. Okay, so I got my butane down. Now it says trimethyl, which means I know I'm going to need 3 with only 1 carbon. And where are they located? They're located on 2, 2, and 3. So I'm going to start from my left and go to my right. So this is kind of like carbon 1, carbon 2. So this is where 2 of my methyls will be found. And then I'm going to go to 3, which is my last methyl. And there you have 2, 2, 3 trimethyl butane. Right, and then the next guy, I'm going to find my longest chain, which is hexane. So that would be 6. 1, 2, 3, 4, 5, 6. All right, and where are my branches coming from? I've got some 2 methyls coming from, because of that die, coming from the 2 and the 2. So I'm going to start from the left, going to the right. So this is my second carbon. So I would put a methyl here, which means 1 carbon attached on both sides, because I had 2, 2. And then I would have 3 ethyl. So it'd be, I need an ethyl, which means I'd have 2 carbons. So that's one way you could draw it, or you could draw it like this if you wanted. Either way, it doesn't really matter. But if that makes it easier, then go right ahead. So here's your finalized drawing for 3-ethyl-2,2-dimethylhexane. All right, that's it for tonight on alkanes. Once again, this is entirely extra credit on the test, so if you would like to learn it, that's fine. I do have some practice worksheets for you, and then if you have any questions, just ask. All right, have a great night.